So in part one of the chemical reactions lab, we're going to be looking at single replacement reactions. And we have our test tubes set up as outlined in your instructions. We have test tube 1A, 1B, and 1C. We're going to add into test tube 1A 20 drops of hydrochloric acid, HCl, which is aqueous. And you'll see that the solution is colorless. Into test tube 1B, we're going to add in 20 drops of copper 2 sulfate, which has a very distinctive blue color associated with it. Into test tube 1C, we are going to be placing 20 drops of zinc sulfate, and zinc sulfate also is colorless. Now into our tubes, we're going to be placing a piece of metal according to your instructions. So into test tube 1A that has the hydrochloric acid in it, we're going to place a strip of zinc that we've polished with some sandpaper. We're going to drop that in, give it a quick swirl, make sure that it's mixed in well. Into test tube 1B that has the blue copper 2 sulfate solution, we're also going to place a strip of zinc in here. Give that a quick swirl. And then into test tube 1C, we're going to be placing a strip of copper that we've also polished. Give that a quick swirl to see what happens. So we're going to monitor these tubes every 2 minutes. We're going to take a look at them and see how they're changing, and we're going to make some observations in terms of what we see, what we feel, or what we to the touch when we look at these tubes. So after about 10 minutes, we're going to take a look at these tubes again, and what we will do is provide you with some actual photos of the how the tubes end up, because I know it's difficult to see with the video. So I'll describe this, and we'll also give you some information, some data in your lab report. So in 1A, test tube 1A, remember we had our hydrochloric acid with the zinc, and it may be a little difficult to see, but there are lots and lots and lots of bubbles, really tiny bubbles that are being produced right around the zinc metal, the shiny zinc metal in there. That's test tube 1A. In test tube 1B, if you remember, that had the very distinctive blue color of the copper 2 sulfate. If you look closely at it now, you'll see that blue color has lightened a lot. It's become clear, or less blue. And if I shake it up a little bit, you can actually see the zinc that was originally shiny now. It's actually been coated with a sort of a black looking solid. Test tube 1C that had the copper with the zinc sulfate. So there's the copper metal, and there doesn't seem to be any observable changes that have occurred, so we can safely say no reaction for test tube 1C. Again, we will provide you with some photos of some close-ups of the test tubes together with some other observations. So in test tube 1A, we were able to see bubbles being produced. Whenever you see bubbles, that tells you a gas is being evolved. And we can test what that gas is by using a very simple test. We're going to take a wooden splint, we're going to light it on fire, and then we're going to stick it into the mouth of the test tube. And what we observe will give us an idea of what that gas, what the identity of that gas is. So here's our wooden splint, it's on fire. We're going to now take it and put it into the mouth of test tube 1A. You probably heard a pop or a squeak. That is indicative of the presence of hydrogen gas. So in part 2 of the chemical reactions lab, we're going to be looking at double replacement reactions. And what we're going to do is to combine our solutions as outlined in your instructions. So for example, into our first test tube 2A, we're going to place in here 20 drops of nickel 2 chloride, which has a very distinctive sort of a greenish color. So 20 drops go in. And to that, we're going to add 20 drops of the second substance, which is going to be sodium phosphate. So as we add our second component here, we want to make some observations in terms of what we see to that solution, if we see any bubbles, if we see any solids being produced. And then also we can hold the tube to see whether it's becoming colder or warmer. So that will tell us whether heat is being absorbed or whether heat is being produced as the reaction proceeds. So as a reminder, when you mix two things together in a test tube, right, you don't just pour it in. After you pour it in or while you are pouring it in, you want to make sure and give it a swirl to make sure it's mixed properly, or you can flick the bottom of the tube. Okay, so we're going to add to test tube 2A, we're going to add 20 drops of the sodium phosphate. I'll give it a quick swirl. Then as you can see, it has changed somewhat, right? So it went from being that sort of a clear green color, now it looks like it's very cloudy. Looks sort of milky actually, sort of a light green milky color, and that's very different than what we started with. So whenever you see that cloudiness or that milkiness, that is telling us that a solid has been produced, and the term that we give to a solid that's produced when we mix two liquids together, we call it a precipitate. So we're going to do that with each of the combinations for this reaction, and we're going to provide you with some pictures, some photos of the tubes together with some descriptions of the observations. Okay, so in this first reaction, what we are going to do is to take a strip of this magnesium ribbon, and we're going to place it in that flame and make some observations as to what happens to it. And then also we will observe the product that we end up making at the end. So in order to illustrate this more clearly, we turn the lights off, and we're going to take our magnesium ribbon and place it in the flame. So to give you a comparison of what we started with and what we ended with, this is the magnesium ribbon that we started with, and after heating it over the Bunsen burner flame, this is our product. In the last part of the experiment, we're going to first of all get an evaporating dish. We'll make sure it's clean. We're going to get the mass of this by placing it on our balance. We're going to record that mass. And to this, we're going to add approximately 0.5 grams of solid copper 2 sulfate pentahydrate. So we need to get just approximately 0.5 grams into the evaporating dish, and we're going to record the exact mass at the end. Okay, so we have our copper sulfate measured out. We've recorded what that final mass is, and we'll provide that data to you. So our next step would be to take our evaporating dish that has the copper 2 sulfate pentahydrate in it. We're going to place it on a clay triangle that is setting on a ring stand. And what we're going to do is we're going to take our Bunsen burner and we're going to heat this gently so that we can see some changes start to occur with the sample that we have on the inside. After we've heated it for a few minutes, we're going to take a look at it. We'll show you a picture of what it ends up looking like, and then we're going to get the mass of the product here that we get at the end. Okay, so after our sample has cooled and we've taken a look at it, we are going to measure the mass of it. So we place it on the same balance we've used before, and we're going to record that mass and provide that to you. We are then slowly going to add back some water to our product very gently, one drop at a time, and then observe what we see happen. Simultaneously, I have my hand under the evaporating dish, and I can feel that becoming really, really hot. So you can obviously see some changes occurring to the solid that was left behind in here. It was, after we heated it, it became very, very light, almost a white color. We then added back some water to it, drop-wise, and you can see it now resembles the original copper 2 sulfate pentahydrate, and it's giving off a lot of energy. Right? My hand is actually, I can feel the warmth of the evaporating dish as I added the water back to our solid.